Hi, everybody. Welcome back. Today we're going to talk about the differences between categorical data and continuous data and why that's important for statistics. So data is, of course, just a fancy word for information. You could gather all kinds of different information. In human subjects research, for example, we might be interested in religion or age or income or IQ or hundreds and thousands of other things, right? So all of these things that we would be asking, of course, must be variables. Okay, in other words, they must be able to distinguish something about that individual from another individual. Now, they might be the same, of course, but the values that they take must distinguish among each other. For example, let's say I ask somebody, "Hey, how old are you?" And they say, "I'm 25." Then I ask somebody else, and they say, "I'm 28." That value of 25 versus 28 of age in years, obviously, is important because that helps me know how they are different from each other. Now, they could also give me the same number. We're both 26. That's fine. I just have to be able to know what that number means. The 26 must be able to distinguish from people who are not 26, for example. All right. So anything that can vary among the units that you're measuring, in this case people, is a variable. And those variables can take on in many cases, many different values, and in some cases, the values they can take are limited. For example, let's say I ask a bunch of people, did you vote in the last presidential election? Now that's going to have a limited number of answer options. Essentially, you can say yes or you can say no, and there's not really anything else you could say to answer that. However, I could ask, as I said, how old are you? And that would have a large variety of answer options. In fact, you could go up to 120 or whatever, right? You could say, I'm 120 years old, and congratulations, something like that. Or it could be as low as 0, although you'd probably not be verbal at that point, would you? Anyway, but the point is, I can ask these to lots of different people, and they will vary, and the values they can be must be able to distinguish among the other values that they can be. Yes must be different from a no, for example. Otherwise, I'm not getting information. Like, for example, if I said, did you vote in the last presidential election? Somebody says no, and then the person next to them said, I did not vote in the last presidential election. It's the same thing, right? They both just said no using different words, right? So therefore, that would be the same answer essentially, right? Okay, so that's essentially one idea of categorical data. Categorical data distinguishes among the values, but categorical properties essentially don't do anything beyond that. So in other words, if you can distinguish among the different values that the variable can take, then you have given me data that have at least categorical properties. Okay. The best example of this is thinking of just the yes and the no. That's inherently categorical because on the one hand, there's no inherent order to the yes or no. There's no reason for me to say a no goes before a yes or a yes goes before a no. They just indicate differences. So this person over here did vote in the last election and this person did not. Okay, and I know those differences and that's fine. That's wonderful. So that is categorical data or categorical properties inherently is they just give me differences between the values that they can take on. Okay, now why is this important? The difference between categorical data and something like continuous data is that it's going to limit the kind of statistical analyses I can do with those data. For example, really quickly, if I find a whole bunch of people who give me yes and no answers, I can't calculate, for example, an average of answers. I can't find what is the sort of average response between yes and no. That won't make any sense, and therefore I can't do a lot of other statistical analyses. But if I find people's ages, I can calculate their average age. Okay. Now there are some other things we can do with categorical data, and we'll get to all of that. But this is inherently why this is important, is because there are limitations to what we can and can't do with different kinds of data. All right, it's important to note here, of course, that all data must be able to distinguish among the values that it can take on. So therefore, all data do have at least categorical properties, but as we'll get to, some data have more. So for example, let's imagine I'm measuring height among people. 62 inches differs from 71, okay? That must be clear that 62 inches and 71 inches are not the same height. All right. In this particular case, 62 is definitely lower than 71. All right, we should be able to agree with that. Okay, and so therefore all data do have inherently categorical properties at a bare minimum. If not, then you're not collecting any information. Like for example, if I were to get a sample of people and say, "Hey, what planet do you live on?" Everybody would tell me that they live on Earth, okay, unless they have some kind of mental health issue, right? And so if I get a big collection of data and everybody said they live on Earth, that told me nothing because they're not distinguishing at all from each other. And so it's an inherently ridiculous thing to have collected in the first place. Everybody measuring the same on everything is not interesting to researchers. And so we need to be able to have these values that distinguish among one another. Okay, so if all data do have inherently categorical properties at a bare minimum, some variables also have additional properties beyond that. So that's what I'll get into next. Okay, so I talked about the answers to the question about did you vote in the last presidential election, and that took on yes or no, okay? However, when I ask about age, that will cover a much wider range. And additionally, it can go from anywhere from about 0 on up to, there are of course some practical limitations right now. But the point is they can distinguish from each other, and I can know other things about the kinds of answers that they give me. For example, there's an inherent order to the answers people would give me on age. As I said, for example, 0 we could all agree is lower than 3. And 10 is higher than both of those, okay? And so if I can do that to the answers people give me, I can put them in an inherent order, then these data have continuous properties in addition to the categorical properties they have, okay? Sometimes it's talked about as in categorical variables are inherently different from continuous variables. That's fair. However, it's not as if continuous variables do not also have categorical properties. So that's the kind of thing that sometimes gets a little misconstrued, I think. Anyway, so and other things are also important about continuous variables. For example, some continuous variables will also allow you to measure things like this, that 2 years is exactly 5 years less than 7 years, for example. In other words, they've got inherent equal spaces between all of the values that they can take on. So this is all very important. And once again, yes and no does not have an inherent order or a distance between yes and no. There is no distance whatsoever. It's just their different properties, right? Different categories in that case. Okay, so this is all very important information to keep in mind. We need to understand the data that we're using and whether it has continuous properties or not. Some don't and some do, but it's important to know the difference. So as I said, a continuous variable must have order to it at a bare minimum. In other words, the values it can take on must be able to have some order to it, and we really should all be able to agree what that order is. So for example, I could ask a bunch of people, what is the make of your car? Who manufactured your car? And there are lots of different answers that people could give. There are maybe 100 different companies out there that manufacture cars. For example, Chevrolet, Ford, Volkswagen, Nissan. Now what's interesting here is even though it can take on a lot of different values, there really is no inherent order that everybody could agree on in putting those things in together, those different manufacturers. For example, what we would probably end up doing is, well, let's just alphabetize all those kinds of different manufacturers, but really there's no reason for that except for convenience, okay? So in other words, if Chevrolet and Ford, which one comes first? Aside from alphabetizing it, there's really no reason to put any one in front of the other. So if it's arbitrary at all, that's a really good indicator that that has just categorical properties, but really not anything else. So here's just a visual of that same idea. If you can sort of visualize the different values that a variable can take on and see, do they overlap? Is there any reason that, for example, Nissan shouldn't go here and Ford should go here or anything like that? If there really is no clear reason that we should put them in any kind of particular order, or if not everybody would agree on that, then that's a really good indicator that this is categorical data. As you can see here, Fiat down here at the bottom. Why should Fiat not go before Ford? Why should Mercedes not go after Chevy? Now, you could find other things about those car companies that you could use to order them in, but simply indicating what company it is just an indicator of categorical properties. It's just different companies. So if all it is indicating is difference, that's categorical by itself. Okay. However, in contrast, continuous data do have, at a bare minimum, an inherent order to the value they can take on. Okay. So it must be able to be ordered. For example, time is inherently continuous in nature because it has shorter time periods and longer time periods. Everybody can agree what time is shorter and longer. 54 minutes is less than 58 minutes, for example. All right. Now, of course, unless you get into all kind of Einsteinian kind of stuff about the fact that time doesn't actually exist, it's just an illusion of the mind, which I won't get into. For our purposes in research and psychological research, we treat time as a continuous variable. Okay, lots of other variables are inherently continuous because they have different values that span in different values. Weight inherently has lower values than higher values. IQ, age, all that kind of stuff. So there are lots of continuous variables. Okay, so just a quick wrap up is all data, if it's useful at all, must have at least categorical properties, meaning it distinguishes among the values it can take on. For example, like brown and blue, those must be different or you're not giving me any information. It's useless. Okay, now some variables do have only categorical characteristics and others have beyond categorical characteristics. They start to get into continuous characteristics. So those are called continuous properties. There are also lots of different properties that we're going to talk about in the next presentation of continuous variables or continuous data. So that's it for now. We'll get into that stuff next. Thank you very much.